Hi folks, welcome to Solara Technical. In today's video, I'm jumping over to a new series covering what I've seen as the 7 sins of system design. In my last video, I reviewed IEEE's 946, section 5.2. The link's at the end of this video. I know it's cheesy and everybody asks you to do it. Still, please like this video and subscribe to the channel. It really does help with YouTube's algorithms. Typically, we get over 1,000 views per video. I challenge you to help us get 100 likes on this video. Thank you. Why this topic? As power folks, we often get asked to help with grounding, lightning, noise, and safety issues. This happens since it's very common for our customers to be domain experts in something other than these topics. It makes sense they might need a little help. Here are my top 7 sins of system design. These 7 reach beyond power and grounding, and I hope they will help you with your next system design. 1. Not challenging everything. Ask why you're doing anything. Is it needed? What does it do for you? Is there a new or better way of doing it? Because we've always done it that way is not the best reason, and it will usually be more expensive as well as limiting. 2. Not designing from the loads backwards to the power system. Picking the power first will always result in the incorrect system. So, try to reduce your loads as much as possible while leaving room for expansion. Design in a modular format, always placing the equipment where it's needed. This will reduce cable congestion. When cabling, have all the cables flow in a waterfall format, resisting the temptation of going down the rack to get to gear only to go back up the rack to connect to something else. Be sure to have all the equipment face the same direction. Think in terms of a cool aisle and a hot aisle. When selecting gear, pick products where cables connect in such a way as to maximize rack density. 3. Being inconsistent. Nothing is more frustrating than trying to run down a problem in multiple deployments where, for the same function, things are done differently. It's almost impossible to know where to start. Systems are seldom designed this way. Instead, they evolve into this over time with replacement and expansion initiatives. Resist undocumented changes and allowing someone to just get it done. 4. Not using a single point ground. Watch out for ground loops. It's important to always know where the current is flowing. Think in terms of islands and sub-islands. Connect everything back to a single point master ground bar. If your equipment exceeds 20 feet apart, use multiple ground bars. If you're in a data center with very long rows, consider running everything within a row to the center of that row and placing your ground bar there. 5. Not using the short path for connections, especially grounds. If you have a raised floor deployment, don't go up to the ceiling only to go back down the wall to get under the floor. Just go under the floor directly. Using 100-foot plus ground runs only conducts DC currents and usually will add to noise issues at frequency. 6. Leaving signals to float. You may think you're floating signals, but everything has a capacitance, and at frequency, that capacitance will ground the signal, usually not where you want it to. So, ground everything the way you want it grounded and where you want it grounded. This is needed for input power, output bus voltages, and the positive lead of negative 48-volt plant. Everything. 7. Not managing inductance. Just because a wire connects 2 points, don't assume it's done the job you want it to. Lead inductance matters. Increasing round wire gauge does little to reduce inductance. Instead, use flat ribbon cable. Cable bend radiuses matter. Tight bends increase the inductance of the cable. Treat cables like you would conduit. Use gentle bends everywhere. As always, if you'd like help with anything related to power, please give us a call. We're here to help. Thanks for watching.